So now that we know how to take the derivative of an inverse function, let's find the derivative of the square root function. Okay, so we're going to do the square root function as an example. And once you see the idea, then we will consider more general roots. Okay, so let's consider first this squaring function. This one won't actually work. Suppose that s sends reals to the reals, defined by f of s of x is equal to x times x, which equals x squared. S fails to be one-to-one and onto, and as a result, this does not have an inverse. Okay. So let's modify this a little bit. Let's say that S sends 0 to infinity, not including 0, to 0 to infinity, not including 0, defined by s of x equals x squared. You should be able to check that this is both one-to-one and onto, and therefore S has an inverse function. So S inverse acts from 0 infinity to 0 to infinity, and it has the property that S inverse of S of x equals x for x in the domain of S, and S of S inverse of y is equal to y for y in the domain of S inverse. Okay, so I can take that first equation and I can differentiate it using implicit differentiation and the chain rule. And then I will solve for the derivative of the inverse function. Some notation I should mention. We commonly write square root of y for y greater than or equal to 0 for the positive real, such that square root of y times the square root of y is equal to y. Another notation that we use is y to the 1/2. Okay. And so this S inverse of y is basically either root of y or y to the 1/2. Okay, so if we let y equal s of x, then S inverse of y equals s of x is equal to x. Then the chain rule says that the derivative with respect to y of S inverse of y times the derivative with respect to x of s of x is equal to the derivative of x with respect to x, which is equal to 1. As long as we're not dividing by 0, then we can say that the derivative of S inverse with respect to y is equal to 1 over the derivative of S with respect to x. And the derivative of S with respect to x is the derivative with respect to x of x squared, which is twice x. So the derivative of the inverse function with respect to y is equal to 1 over twice x. Okay. Now we can solve for the x because x is equal to the root of y. So the derivative of S inverse with respect to y is equal to 1 over twice x, which is equal to 1 over twice the root of y. And now if I write S inverse as root of y, I get that the derivative with respect to y of the root of y is equal to 1 over twice the root of y. Okay. If we use the other notation, y to the 1/2 instead, we would get that you can either have the derivative with respect to x of the root of x equals 1 over twice the root of x, or you can have d by dx of x to the 1/2 is equal to 1/2 x to the minus 1/2, which kind of looks like a rule that we already know for integers, but now it seems to also work for 1/2. Okay, as an exercise, I'll leave you with this. Define S goes from minus infinity to 0 infinity by S of x equals x squared, and then take the inverse to be mapping from 0 infinity to minus infinity 0. So S inverse of y is equal to minus the root of y, and see what you get for the derivative of that function. Now we will move on to considering more general roots, and then roots, and then rational roots of rational